Hello my friends, and welcome back to the Today Machine channel.
ArcelorMittal Jubail, a state-of-the-art seamless tube plant in Saudi Arabia, caters to the growing demands of the oil and gas industry. Located in Jubail's second industrial city, 25 kilometers from the Arabian Gulf, the plant has a production capacity of 600,000 tons annually. The production process begins with billets sourced from ArcelorMittal's steel plant in the Czech Republic. Upon arrival, the billets undergo quality verification and are stored by type and heat. They are then heated in a rotary hearth furnace to approximately 1,250 degrees Celsius. The piercing mill transforms the heated billets into hollow tubes, which proceed to the premium quality finishing (PQF) mill. This advanced technology ensures precision in wall thickness using ultrasonic online measurement. After normalization in an induction furnace, the tubes pass through a 12-stand sizing mill and cool on rotating beds to maintain straightness. Semi-finished tubes, up to 42 meters long, are further processed through cutting, straightening, and rigorous inspections, including magnetic flux leakage and ultrasonic testing. In the finishing lines, tubes are heat-treated, threaded, and undergo end processing such as upsetting for small diameters. Products are subjected to hydrostatic testing and drift tests before receiving protective varnish and packaging. Dedicated lines for casing and line pipe products ensure high-quality outputs that meet stringent customer specifications. Supported by in-house R&D and testing facilities, ArcelorMittal Jubail integrates quality control with technical expertise to deliver premium solutions while emphasizing workforce competency and safety. The TAG Prep 24 elbow and fittings portable pipe beveling machine is a versatile and powerful tool designed for beveling, J-preps, counter boring, and facing on elbows and pipe fittings. Its robust yet compact design features a heavy-duty shaft and a 6-piece locking jaw system, providing excellent stability and precision during operation. The machine is part of TAG's new range of heavy-duty mid to large diameter beveling machines and is capable of handling internal diameters ranging from 8.26 to 23.62, 210 mm to 600 mm. The Prep 24 is equipped with ratchet feed and locking mechanisms, which enable effortless setup and smooth, consistent operation with minimal effort from the operator. The ratchet feed system ensures precise beveling, even on heavy wall pipes. The machine is powered by servo-electric, pneumatic, or hydraulic options, offering flexibility depending on the user's needs. It supports various functions including external and internal beveling, facing, counter boring, weld removal, J-prepping, and compound bevels, making it ideal for use on a wide range of materials, including steels and exotic alloys. Its user-friendly controls and efficient design make it suitable for industrial environments where precision and durability are key. The manufacturing process of hot-rolled bright round bars involves several key stages designed to produce high-quality bars with a polished surface and precise dimensional accuracy. Raw material selection. The process begins with selecting high-quality hot-rolled billets as the primary raw material. Hot rolling. The billets are heated and passed through a 250 rolling mill to reduce their diameter. The hot rolling process forms bars with diameters ranging from 8 mm to 50 mm, ensuring improved strength and flexibility. Peeling. To achieve a smooth and polished surface, the bars undergo peeling, removing surface imperfections and creating a bright appearance. Calendaring and straightening. Calendaring improves surface finish and dimensional accuracy, while straightening ensures uniformity and reduces warping. The process begins with drop forging, where heated steel rods are shaped using powerful forging presses. This creates the rough outline of the pliers, ensuring durability and strength. Next, the forged pieces undergo trimming and cutting to remove excess material, followed by precision machining for accurate shaping of the jaws and pivot holes. This ensures the pliers parts fit together seamlessly. The critical heat treatment stage enhances the pliers' hardness and toughness. The jaws receive additional induction hardening, making them resistant to wear. Skilled technicians then perform grinding and polishing, creating smooth, sharp cutting edges and refined surfaces. For assembly, the pliers' halves are joined at the pivot point and adjusted for perfect alignment. Next, handle dipping is performed, where handles are coated in signature blue rubber for comfort and grip. The factory uses advanced dipping machines for consistency. Finally, inspection and testing guarantee every tool meets Keiba's strict quality standards. Each plier is tested for cutting performance, grip comfort, and precision. Closed die forging is a manufacturing process in which a metal billet is placed between two dies and compressed under high pressure to create a desired shape. The dies, which are precisely shaped to the final part geometry, are closed around the billet, and the metal is forced to flow and fill the die cavity. The process is typically performed at elevated temperatures, known as hot forging, although it can also be done at room temperature, cold forging, for certain materials. In terms of pressure, closed die forging typically operates at forces ranging from 500 to 25,000 tons, depending on the size of the part. For example, a 1-ton part may require a pressure of around 2,000 tons, while larger components can require much higher forces. The process offers excellent material properties, such as improved strength, durability, and resistance to wear due to the metal's grain structure being aligned with the part's shape. The metal flow during forging is highly controlled, allowing for complex geometries and reduced material wastage. The process is used for manufacturing parts such as automotive components, aircraft parts, and industrial machinery, with typical sizes ranging from small, intricate components weighing a few grams to large structural parts weighing several tons. The M35 Milturn multifunctional turning boring milling centers are advanced machines designed for complete machining of complex shafts and chuck parts. They accommodate workpieces with a swing of up to 520 mm and machining lengths of up to 2,000 mm, offering versatility by functioning as a lathe, 5-axis machining center, gear cutting machine, or deep hole drilling machine. The M35 Milturn demonstrates its capabilities by performing various processes, including rough and finish turning, turn milling, boring with AO 40 mm bar, rough milling, drilling with AO 45 mm bit, finish milling, and chamfering. These tasks are executed efficiently, with a total machining time of 360 minutes. The machine's unique Milturn concept combines all machining and measuring operations, significantly boosting productivity and precision. Its vibration-damped boring bars and gear-driven turning boring milling units ensure exceptional chipping performance. The production process at Kuznia Ostra Wielkopolski is a comprehensive journey that begins with the reception of raw materials and culminates in the precise mechanical processing of finished components. This process spans several critical stages, each contributing to the creation of high-quality die and open die forgings for industries such as railway, machine, agricultural, hydraulic, and mining. The first step in the process is the acceptance and inspection of raw materials. Steel is the primary material used, and it is carefully evaluated to meet the required standards for further processing. Once the material is approved, it proceeds to the preparation stage, where it is heated to the necessary temperature in preparation for plastic deformation. The next stage involves plastic working, where the steel undergoes forging using various machines, such as the Hammer MPP 16 terameters and the Hammer MPK 3150. These machines apply immense force to shape the steel into the desired forms. The MPP 16 terameters is used for closed die forgings, with an attack energy of 160 kilojoules, while the MPK 3150, a free forging hammer, handles larger components weighing up to 1,000 kilograms. This stage is crucial for ensuring that the components have the correct size and shape for their intended use, such as screw couplings, draw hooks, or railway axles. Following the forging process, the components undergo heat treatment to enhance their mechanical properties. Heat treatment is a critical step, as it ensures the parts possess the necessary strength, hardness, and durability for demanding applications. The parts are then carefully cooled under controlled conditions to prevent any damage. After heat treatment, the components move to the mechanical processing stage, where they are precisely machined to meet specific tolerances. This is achieved using CNC machines, including lathes and milling machines designed for forging and die work. The CNC machines provide exceptional accuracy, ensuring that each component meets the high standards set by the company and its clients. The company offers a wide range of products, from small die forged parts weighing 0.5 kilograms to large open die forgings up to 1 ton. The company's extensive experience, technical equipment, and skilled workforce guarantee that each product meets the highest standards of quality and performance. The TrueBend Series 5000 is Trump's most successful and productive bending machine, renowned for its unmatched efficiency throughout programming, setup, and bending processes. It incorporates cutting-edge features and user-friendly innovations to maximize productivity while ensuring ergonomic operation. The on-demand servo drive powers the machine with exceptional speed, 8.5 in/s, quiet operation, and energy efficiency. It ensures smooth and precise motion, enhancing overall productivity. Operators benefit from advanced angle measuring systems, like the ACB wireless and ACB laser, which guarantee perfect results even from the first part. The innovative ACB speed feature reduces cycle times by up to 35%, while the Smart Materials database offers dynamic flexibility for different materials. Ease of operation is ensured by the Touchpoint True Bend control system, which functions as intuitively as a tablet PC. The machine is also equipped with a Toolmaster automatic tool changer, eliminating manual setup time for tools, thereby streamlining workflows. The 6-axis back gauge provides unparalleled production freedom, enabling complex and diverse bending applications. The lower tool displacement feature facilitates specialized tasks such as folding, while integrated LED illumination ensures the work area is brightly lit without generating heat. With features like thickness-controlled bending and enhanced ergonomics, the True Bend Series 5000 delivers exceptional versatility, precision, and productivity. China is the world's largest producer of steel drums, leveraging its vast industrial base and advanced manufacturing technologies. Steel drums are widely used in industries such as chemicals, petroleum, food, and hazardous waste management, thanks to their durability, recyclability, and ability to store and transport liquids or powders safely. In 2023, China's steel drum production capacity exceeded 200 million units annually, representing about 35% of the global output. The industry is driven by domestic demand from China's booming industrial sectors and growing export markets, particularly in Asia, Africa, and the Middle East. Chinese manufacturers provide a wide range of steel drums, including standard 55-gallon drums and custom-made sizes, catering to diverse industrial requirements. China's steel drum production is concentrated in regions like Guangdong, Jiangsu, Zhejiang, and Shandong provinces, known for their strong industrial ecosystems. Leading companies, such as Shanghai Drum Corporation, Kaiming Packaging, and Grief China, play a significant role in both domestic and international markets. Many of these manufacturers are equipped with state-of-the-art automatic production lines that integrate processes like sheet metal cutting, welding, surface treatment, and painting to ensure efficiency and quality. Industrial expansion. The rapid growth of the chemical and oil industries in China has fueled demand for steel drums, especially for bulk transportation and storage. Export growth. In 2023, China exported approximately 50 million steel drums, a 10% increase compared to 2022, with key markets being India, Southeast Asia, and Africa. Sustainability trends. With the global emphasis on sustainable packaging, Chinese manufacturers are investing in recyclable and reusable drum designs, boosting demand. The industry faces challenges, including rising steel prices. Fluctuations in raw material costs impact profit margins. Environmental regulations. Stricter emissions and waste disposal laws require upgrades in production processes, increasing costs. Global competition. competing with other large producers like India and the US in terms of quality and price. The steel drum industry in China is expected to grow at a compound annual growth rate, CAGR, of 5% over the next 5 years, driven by industrial diversification, technological upgrades, and increasing export opportunities. With continued investments in automation and sustainable practices, China will likely maintain its leadership in the global steel drum market. The casting process for slag ladles at Great Wall Steel Casting Company employs advanced steel casting technology and state-of-the-art facilities. The company utilizes CAE software for digital simulation, which significantly enhances the precision and efficiency of the casting process. A slag pot, an essential device in steelmaking, serves as a load-bearing container designed to collect molten or solid slag produced during metallurgical or chemical processes. Typically bowl-shaped, the slag pot features lifting lugs on either side for easy handling and a grilling system inside that divides the inner space into multiple sections, with a depth of at least 300 millimeters. This design ensures effective containment and cooling of slag. Traditionally, slag pots were cast using standard methods, which often resulted in lengthy manufacturing cycles, shorter service lives, and higher scrap rates. However, Great Wall Steel Casting has innovated the process to improve these factors. Their advanced production techniques have shortened the casting period, extended the service life of slag pots, and enhanced their resistance to deformation. The ring forging process begins with blanking, where the raw material is prepared by cutting it into the required size. The raw material is typically steel, and its chemical composition is carefully analyzed to ensure it meets the required standards for strength and durability. The material is then heated to a specific temperature to make it more malleable for forging. In the forging stage, the heated material is shaped by applying pressure, either through hammering or pressing, to form a ring shape. Roll forging may also be used to gradually form the ring to the desired dimensions, creating a more refined and precise product. Following forging, heat treatment is applied to enhance the material's hardness and strength. Rough turning is performed to remove excess material and bring the ring closer to its final dimensions. The part may undergo another heat treatment cycle for further material refinement. Hobbing is used to cut internal teeth, and quenching is done to harden these teeth. Afterward, the ring undergoes thorough inspection to ensure it meets quality standards. Non-destructive testing, including magnetic particle testing, is carried out to detect surface and subsurface defects. Dimensional inspection ensures the ring's measurements are accurate. Finally, the part is packed for shipment, with a coordinate measuring machine inspection conducted to verify precision before delivery. It begins with selecting high-quality alloy steel, ensuring strength and durability. The steel undergoes cutting using a 1000 to 1600 Tera-Newtons force press. Next, forging and hot trimming at 1150 degrees Celsius shape the wrench's basic structure. Normalization at 860 degrees Celsius relieves internal stresses, followed by shot blasting to clean the surface. Punching and coining refine the top adjustment features, ensuring a smooth operation. Polishing enhances the wrench's grip comfort, while machining through broaching ensures precision fitment. Hardening and tempering involve induction heating to 860 degrees Celsius, boosting strength and wear resistance. The surface is treated with chrome plating or phosphating for corrosion resistance. Assembling includes attaching the moving jaw and adjusting knurl for precise adjustments. Tip polishing ensures proper alignment, and periphery grinding smooths jaw edges. Laser marking provides a precise metric scale. Finally, handle assembly with thermoplastic elastomer ensures a firm, oil-resistant grip and comfort in extreme temperatures, -40 degrees Celsius to 100 degrees Celsius. Matco Tools ratchets are engineered for durability, precision, and long-lasting performance. The manufacturing process combines advanced techniques and high-quality materials to produce industry-leading tools. Spin welding for strength. The ratchet handle and head are joined using spin welding. This process generates heat through high-speed friction, creating a seamless, strong bond that enhances the tool's durability and resistance to stress during heavy use. Induction heating. Key components undergo induction heating, where an induction coil heats metal parts to 1,200 degrees Celsius, 2,192 degrees Fahrenheit. This precise and efficient heating process ensures uniform hardening, increasing the ratchet's strength and wear resistance. Surface preparation with ceramic stones. This step removes surface imperfections, creating a polished finish that enhances both appearance and plating adhesion, ensuring a long-lasting, corrosion-resistant surface. Hexavalent chromium coating. To protect against rust and wear, the ratchets receive a hexavalent chromium coating. This durable finish not only provides superior corrosion resistance but also gives the ratchet its signature bright, polished look. Raw material. Jonnesway wrenches are crafted from premium steel supplied by Taiwan's China Steel Corporation, known for producing top-grade steel. The high-quality steel enhances the wrench's durability and performance. Forging. The steel is heated to approximately 1,000 degrees Celsius and rolled to increase its strength and reduce stress points. It then undergoes forging using a 3-die press process. The first die shapes the general form, the second creates the precise contour, and the third die cuts the blank. Chemical grinding. The forged blanks are placed in a container filled with a chemical solution and ceramic stones. This grinding process smooths out rough edges and removes surface imperfections. Polishing. For mirror-polished wrenches like the Jonnesway W26 series, technicians hand-polish the blanks, creating a smooth, reflective surface. Stamping. Next, the wrench is placed on a stamping press, where the Jonnesway logo, size, and item number are embossed. This step not only marks the tool but also enhances its structural hardness. Heat treating. The wrench undergoes heat treatment to optimize its strength and hardness, ensuring long-lasting performance even under intense pressure. Hardness test. Quality control engineers perform a hardness test on the wrenches to verify that they meet Jonnesway's stringent durability standards. Sandblasting. Sandblasting removes carbon residues left from heat treating, preparing the surface for further treatment. Chemical grinding. Additional, mirror-polished wrenches receive a second round of chemical grinding for an ultra-smooth finish. Open-end grinding. The wrench's open end is ground using 3 specialized grinding stations to ensure precision fitting. Cleaning. Technicians clean the wrench, removing lubricants and trimming any sharp edges for safety and usability. Plating. Jonnesway employs a specialized plating process that enhances corrosion resistance and ensures a uniform, protective finish. Testing. Finished products are subjected to rigorous testing, including torque, hardness, and corrosion resistance tests. Samples are salt spray tested for 48 hours to ensure plating integrity. Packing. After passing all inspections, the wrenches are packaged carefully to prevent damage and allow for a final visual check before delivery. A fully automated pump manufacturing plant in China integrates advanced technologies to ensure seamless production, from raw materials to final products. The impeller housing automatic stamping line utilizes progressive die technology for precision stamping, followed by punch cleaning for optimal surface quality. An AGV logistic line efficiently transports components across production stations, minimizing manual handling. For the impeller inner brace, a robotic stamping line enhances accuracy and consistency, reducing production errors. The plant incorporates an automated stereoscopic warehouse to optimize storage, enabling quick retrieval and inventory management. The assembly, testing, and packaging processes are consolidated into an integrated automatic line, ensuring precise assembly, rigorous quality testing, and efficient packaging without interruptions. These innovations streamline production, reduce labor dependency, and maintain high-quality standards, positioning the plant as a leader in modern pump manufacturing. The screwdriver production line consists of multiple automated processes that transform raw materials into finished screwdrivers or bits. Here's a step-by-step breakdown. Raw material preparation. Steel rods or bars are fed into a straightening and cutting machine, ensuring uniform lengths suitable for further processing. Forging and edge cutting. The prepared pieces undergo raw material forging to create the basic screwdriver shape, followed by edge cutting to remove excess material and refine edges. Head and end shaping. The slotted head and flange end machine precisely shapes the screwdriver's head and flange for different bit types such as Phillips, Pizzidrive, slotted, and Torx. Stamping. Logos, size marks, and other identification details are applied using a stamping machine. Heat treatment. To enhance durability, screwdrivers undergo heating treatment machinery processes, including tempering and quenching. These processes improve hardness while retaining flexibility. Cooling. After heat treatment, the parts are cooled through oil cooling methods, ensuring proper material structure stabilization. The HTM1000 is a highly capable and versatile 8-axis horizontal turning and milling machine, designed specifically for machining large components like diesel engine crankshafts. Its robust construction and advanced features make it a perfect choice for industries such as shipbuilding, energy, and heavy machinery manufacturing. Equipped with a Siemens CNC controller, the HTM1000 offers precise and efficient control over complex machining operations. The machine features a powerful 52 kilowatts main drive motor that delivers the necessary torque for heavy-duty tasks. Its B-axis head combines driven and fixed stations, allowing for complex angular machining and maximum tooling flexibility. This advanced functionality reduces the need for multiple setups, saving time and ensuring consistency in machining operations. The machine's dual milling heads enhance its productivity and versatility. One of the milling heads is a specialized 69 HP gear-driven unit, designed for heavy-duty roughing and efficient material removal. Both heads are capable of performing precision milling, making them ideal for machining intricate geometries. The primary head supports fixed and rotating tools, providing flexibility for a wide range of applications. Additionally, the machine's automatic tool changer system facilitates quick tool changes, boosting overall productivity. To handle the machining of long and heavy components like crankshafts, the machine is equipped with steady rests and other support systems. These ensure the stability of the workpiece, minimizing vibrations during the machining process. The B-axis functionality further enhances the machine's capability, enabling operations such as angular drilling, contouring, and the creation of complex features with high precision. The machine is particularly suited for the production of large diesel engine crankshafts. During this process, the crankshaft blank is mounted securely between the machine centers, while steady rests provide additional support. The milling head and turning tools work in tandem to perform roughing, finishing, and the machining of critical features such as crank journals, balancing elements, and keyways. This seamless integration of turning, milling, and drilling capabilities within a single machine reduces production time and ensures high-quality results. As a turnkey solution, the HTM1000 meets the demands of facilities handling large-scale projects. Its ability to integrate multiple operations into one machine enhances efficiency and reduces the need for additional equipment. Aqua Group has been at the forefront of pump production since 1956, producing over 2,500 pumps daily and earning a reputation as India's #1 pump manufacturer. The production process begins with meticulous design using advanced CAD/CAM technology. Rapid prototyping through 3D printing accelerates the introduction of new models to the market. Aqua Group's in-house automated foundry produces defect-free castings of gray iron, non-ferrous, and stainless steel using electric induction furnaces and spectrometer-analyzed molten metal. This ensures unparalleled strength and durability. Motor components are fabricated internally, with facilities for motor lamination, copper wire production, and heat treatment, ensuring the highest efficiency and quality. Automated CNC machines handle part finishing with micron-level precision, virtually eliminating defects. Hydraulic and electrical testing of each pump guarantees reliability even in rugged conditions, including voltage fluctuations common in rural India. The assembly lines incorporate automated stator winding and advanced impregnation techniques, enhancing insulation resistance and longevity. Pumps are coated and dried to perfection for a flawless finish. Aqua Group's dedication to quality extends to specialized production units for stainless steel pumps, meeting global standards and supporting exports to markets like the Middle East, Japan, and France. The TAG split frame clamshell cold cutting and beveling machines are designed as portable, versatile pipe and vessel machining tools, capable of handling a wide range of cutting and beveling tasks. These machines are available in sizes ranging from 1 inch to 48 inches OD, 25.4 mm to 1,220 mm, with custom options for larger sizes. Their key functions include external and internal beveling, counterboring, compound bevels, and J-prep beveling. These machines are suitable for use with various materials, including steel and exotic alloys. The machines feature a lightweight aluminum body that houses a steel inner ring gear running on solid bearings, providing both strength and durability. The robust design ensures the machine can be easily handled while maintaining high performance. The clamping feet, which are wide and hardened, allow for quick, repeatable concentric setups, even on out-of-round pipes or joints. The easy-to-read rule marks on the feet aid in fast adjustments and accurate alignment. The TAG split frame clamshells come with a variety of tooling, power units, and accessories, allowing for customization based on specific job requirements. The power options include pneumatic, electric, 110 volts or 220 volts, hydraulic, and servo-electric motors, offering flexibility for different working environments. Maintenance is made easy with adjustable heavy-duty bearings and accessible inspection points, enabling straightforward adjustments and upkeep.